Some helpful tips about doing regression curves in Desmos. Sometimes you're asked to find the equation of some kind of object. Right now we're working on quadratics, and some people have asked me about them. So the first thing to know is in Desmos, there's a little plus sign. You can do an expression, a note, a table, or other stuff. So I'm going to do a table, and that table is where I can put my x and y values. So recently we had a problem like this. It said, a ball goes up, and after 1 second, it's at 6 feet. After 2 seconds, it's at 22 feet. At 4 seconds, it's at 22 feet again. So it must have gone up and then come back down. And then at 6 seconds, it's back down at 6 feet. So we get something like that. You can look at the data like that. You can scoot you can zoom out and see what's going on. But really what I want to focus in on what the quadratic regression is going to be. Or in this case, it's quadratic because it goes up and then down. And we know it's if it's a ball, then obviously that's what balls do. They go up and then back down. So what we do is we take whatever the y value is. This is a y1 and this is x1. We say y1, and then this symbol that's on top of the tab key, it's called the tilde. The tilde says it's not equal to, it's we're trying to figure out the equation that looks like this. So ax1, notice when I type the 1, it does ax1 subscript, and then do squared by doing the caret key like we usually do. And then bx1, or I should put a plus sign in there, sorry, plus bx1 plus c. So this equation, y sub 1 tilde ax1 squared plus bx1 plus c, is telling the computer that it wants to take those points up here in my table and make something out of it. And as you see it did, it created a parabola that went through all the points. In fact, I know it went through all the points because the coefficient correlation here, the correlation coefficient r squared is equal to 1. If it was, those numbers are always between 0 and 1. The closer they are to 1, the better the relationship. The a value in this expression is -2. That's the coefficient of x squared. The b value, the b one is 12, and the constant is 6. So here's a further thing, and that's the regression. So if you were going to ask about this equation, you could say forget about these equations. This correlation will do this. We'll just say f of x is equal to, and I'm going to use the a value, -2x squared. B value is 12, so plus 12x, plus 6. And that parabola, using this a, b, and c value, goes through all 4 points. Now, the reason why I did it this way is because another question that you're often asked is, like on this question, it says, what happens at time 5 seconds? So because I did it as an f of x, now I can type f of 5. What happens when x is equal to 5? And notice that the answer is right there. It's 16. So I could look on the chart. You know, if I had blown it up properly, I would be able to see what happens at x equals 5. But might as well have Desmos do it for me. Another type of question asks just the opposite. It says, when does it reach 20 feet high? And for that, you might do something like this. Since the 20 feet is a y value, you'd say, well, how about if we say y equals 20? I'll type it right. Y equals 20. And notice that the green line goes through the parabola in 2 places. So over here at 1.586 seconds, and over here at 4.414 seconds. So there's 2 different things going on. One is evaluating at a particular seconds, like 5 seconds. And another is saying, well, if you know how long does it take to get to 20 feet, you could do it like this. This is one of the options. So I hope this helps with quadratic regressions and other regressions that we're doing in class.